All right, in this problem, we're given a graph of f and g, and we can see that both f and g are piecewise linear. So in pieces, they're linear. And we're going to find the derivative of functions which are compositions of f and g. So u is equal to the function f composed with the function g. And when I take the derivative, I'm going to use the chain rule. So I use the chain rule here and get that u prime of x is f prime of g of x times g prime of x. Now let me try to say something that could possibly make this a little easier to see what's going on. We have two functions f and g. Essentially what the chain rule is saying is that I take the derivative of f and I take the derivative of g and multiply the two together. That's what we see. We see f prime times g prime. Now we also see that inside of f prime, we plug in g. That's what we did with f. We put g in for f. We do the same for f prime. But really, we see it's f prime times g prime. Now, when I put in numbers, I'm going to put one number in particular. I'm going to put x is 1. So I have f prime of g of 1 times g prime of 1. Well, what I need to do now is I need to determine what g of 1 is, what g prime of 1 is, etc. So g of 1 is found by looking at the graph. So I look at g, which is in blue, and I'm looking at x is 1, and I see y is 3. All right, so that is getting there just piece by piece. I'm going to replace g of 1 by 3. Now, g prime of 1 is a little more tricky. This is the slope at x equals 1. Sorry, g prime of 1, is that what I said? G prime of 1 is the next thing I'm going to work on. G prime of 1 is the slope when x is 1. So I look at, I look at 1, and I'm looking at this g graph, which is in blue, and I have 1 point, and now to find the point of the slope of this line, I need another point. Which one will I fix, or which one will I pick? I'll pick another point where the two coordinates are integers. And then I use the old rise over run, where I make a right triangle and I count, and I see that I'm going down by 3 and to the right by 1, so that makes a slope of negative 3, which is the derivative. The derivative is the slope of the tangent line, and since this is g is a straight line at 1, it'll be the slope of that line. Now I do the same sort of thing for f prime of 3, which is I'm going to I'm going to look at the line which is in red for f at x equals 3, and so at 3, at 3, f is not passing through a point that has integer values for its coefficients or for its coordinates. So what I'm going to do is I'm going to pick a couple over here, one to the left, one to the right, where I can then count easily that I'm going down by 1 and over to the right by 1, 2, 3, 4. And so it's going to be down by 1, so it's negative 1, to the right by 4, and I get negative 1/4. And these things are, they're easy to, for me at least, to make little mistakes along the way. So a bit of all this stuff is that whole idea of looking at things carefully, the attention to details. It's not for everyone. And anyway, it's one part of math. A lot of things have been moving to computers anyway. But okay, let's look at what V is. So V is something similar, but this is a composition where V of x is this times g and then composed with f. And so then V prime of x is using the chain rule, the derivative of g, I see g there, multiplied by the derivative of f. And what do I put in g prime? I put in f of x. So then I have v prime of 1 is equal to g prime f of 1 times f prime of 1. Let's see if I can redo anything. I don't know if I can. Let's see. So f of 1 is equal to, let me first focus on this f of 1 bit here. Take away the other highlights for a moment. Okay. So let's look at f of 1. F of 1 is found by that point that I just drew on the graph. It's the red part there, so that's going to be 2. And then f prime of 1 is that's the slope. As before, f prime of 1 is going to be the slope of the red graph. And so if I look at that red graph, at 1, it means it looks like if I erase some of the other stuff, but to go from one point to the other, I'm going up by 2 to the right by 1. So that's 2 over 1. So I can then fill in some of these things. So g prime of f of 1, so it's g prime of 2 times 2. Then I need to find out what g prime of 2 is, but g prime of 2 does not exist. Why doesn't it exist? Well, because we have a sharp edge there. A so-called kink in the graph. If you have a kink in the graph, there is no tangent line, and that's one way to think of it. There's no tangent line, and the derivative does not exist because you could think of it because there's no tangent line. We showed that, by a rigorous proof, that for absolute value at that kink, the function of absolute value is not differentiable. The derivative doesn't exist. So this sort of looks like absolute value in a way. Okay, but only in some ways. All right. Now let's look at W. W is equal to G composed with itself. So by the way, in the end, the answer to that is that v prime of 1 does not exist. Okay, now going on to W. Well, W of x is equal to G of x, is G composed with itself, G of x. That's what it says up there, right? So it's G of x. The chain rule, which I didn't really write down anywhere along here, so let me write it down. This is all chain rule. So, I have it up there, chain rule. So we have W prime is G prime of G of x, so I take the derivative of G, and then I take the derivative of G again. Well, the first one I put in G of x, the other one I put in x, but it's going to make a difference, actually, I would think. So I have G prime of G of 1, and then maybe I've already figured out what G of 1 is, but I can go over and look at that, times G prime of 1. Well, what is G of 1? According to, all right, so I want to find out what G of 1 is. Apparently I already did that. It's 3. So I then replace, I get G prime of 3 times G of 1. So I'm going on to the next part. I need to figure out what G prime of 1 is. Well, apparently I already did that. That's negative 3. Now G prime of 3, no, I didn't do that yet. So let's work on that. So focus in a little more. So I need to find out what G prime of 3 is. G prime of 3 is, again, the slope when x is 3. And what I'm going to do is I'm going to look at the point on G where x is 2 and the other point where x is 5. Why would I do that? Because those are nodes in the graph where I have integers, coefficients, or integer entries, coordinates. So I have up 2 to the right by 3, so it seems that that's 2/3. I mean, it's so much we've already done, so it'd be disappointing to get that wrong now. So that gives negative 1. So Could be I did it wrong, or I did at the very end. I always like that. Not always, but it's so often the mistakes happen right at the end where it's just almost there, and then I guess I get tired or something, or just too complacent, like I'm coasting in. I think I've already figured this out. That's the whole problem. Okay, there was 3 parts to that, and I checked with the solution in the back of the book. Those are all right. The answers are. I think the way it was worked out was. I hope it was clear enough. So we have those solutions highlighted and made a big mess of the picture, but there we go. Okay, goodbye.